Good day. Welcome to the Solid Experts Technical Tip Series. My name is John Nolan, and today I'm going to show you a technical tip involving the SOLIDWORKS Toolbox add-in in SOLIDWORKS Professional and some general things you may not know about assembly mates. So here I've made a gear assembly, and I've got some offset shafts and a pair of helical gears. Now the way I got these gears is that you do have in your Toolbox design library set, hidden under your standards, is an entire category called power transmission. Now depending on the standard you can have gears and other things in here, but here we have gears and we've got various types: helical, spur, rack, all that so forth. And they do produce themselves according to the AGMA standards or the international standards as appropriate. So that's the first thing. I have the fully detailed gears. I've applied some mates to put them on shafting here, and I've put in a little notch on the shaft so you can see what's going on. Now the thing that I want to do is I want to test the motion of what these gears produce when they're turned and the effect on the shafts. This could be a cam mechanism, could be a 4-bar linkage mechanism, any sort of machine type mechanism that's got a gear train in it. Now if I just click and turn, they're just going to spin randomly, but I want them to spin in a coordinated fashion, kind of simulating the actual gear meshing. How do I do that? Now again, I've mated these. Notice there is a minus sign on them so they are free to spin. There's at least 1 degree of freedom open. Okay? And in SOLIDWORKS, if I go to the mate icon, if you haven't explored it yet, beyond your standard mates there are advanced mates and then mechanical mates. And in fact, there is a gear mate. I'm going to click that on. Now I've previously, in these 2 files, turned on one of the sketches. And I'll show you where that is. Buried under the gear features is this thing called the tooth cut sketch. It's part of every gear that comes from Toolbox, and in here are the diameters for the pitch diameters of all your gears. So now when I do my gear mate, I simply have to select the appropriate diameter from each gear, and it automatically computes the proper ratio. Now these are in fact the same ratio. I'm doing a pair of helical gears, but for spur gears it could be a 12:1, a 5:1, so on and so forth. And notice I'm able to do this without having to calculate from the standard what the pitch diameter is, go look up in the tables what the 2 different diameters there are, and figure out all the ratios. Now that I'm done, I can go back, turn my sketches back off at the assembly level, and as I turn the one gear, it computes the ratio and turns the other gear appropriately, and you can see the notches on both shafts spinning in the correct direction. So again, a couple of tips here. 1, in your toolbox, look in your power transmission. You can find fully detailed gears. In those gears is an item called the tooth cut sketch that you can set to show. With that item, you do in fact have the proper pitch diameters, which you then apply in your gear mate as needed. So again, that saves you the effort of trying to estimate what the proper ratio is, look it up in a table, measure it, use the evaluate. It's all built in there for you. It's just a matter of turning on that sketch and selecting it appropriately for the gear mate. Thank you for your time and attention. This has been another in the Solid Experts Technical Tip Series. Stay tuned next month for another tip from Solid Experts.